Okay, study of effect of open and short circuit in simple circuit. In this experiment, the aim is to study the open circuit and short circuit concept of electrical circuits. Theory behind this experiment is that we need to study the open circuit analysis, closed circuit and short circuit with applying load and without applying the load. So here there is a one closed circuit. The circuit is closed with a resistive load, and the open circuit which is open with a switch, that is open circuit we can do it, and short circuit we can short the across the resistance, that is the short circuit. These are types of circuits available. And the closed circuit, you know that the circuit, the electrons flows in complete path, that will be called as a closed circuit as shown in the figure 1a. And the source of electrons, and there should be a return path through the load, that is called as ground, and that is be called as the electrons always end up with a source and they can complete with an electrical circuit. Open circuit, it is a difference of electrical potential between two terminals and it is disconnected as shown in the figure. There should be external load connected. The potential difference mentioned is battery and cells are open circuit. In this stage, there is no flow of current and the circuit is not closed. And short circuit is an abnormal connection between the two nodes. So you need to short the output side. If there is any shorted in the output, short in the output side, the results in an electrical circuit, it is limited to the only the Thevenin equivalent resistance of the resistance of the network, which can cause a circuit damage and overheating, fire and explosion. A short circuit fault current can within milliseconds be be thousands of times larger than the normal operating current of the system. So this type of prevented by fuses, circuit breakers and other overload protections which can disconnect the power in reaction to the excessive current. So this is one of the circuit diagram for open circuit. In this open circuit, we have single phase input. It is connected to the fuse and there is a voltmeter and ammeter is connected in series with the switches and voltmeter is across the switches. There is three resistance R1, R2, R3. All the switches will be open and the output side is also there is open. Then it will be called as open circuit connection. And with short circuit without load, we are not applying the load, but we need to do the short by using switch S. Here there is a single phase supply. It is connected to the fuse and there is a fuse is connected in series with the ammeter. That is a 5 amps. And there is a S is another switch. It is shorted and it is connected to the phase. And remaining three resistance, it is connected parallelly to the circuit, but it is not connected to the load. There is no, without applying load, we need to do the short circuit condition. So this is the short circuit with load. Here in this case, the single phase supply, it is connected to the fuse and ammeters and voltmeter is across the circuit. Here switch S is open and remaining all S1, S2 and S3, it will be closed because we need to do the short with applying the load. In this stage, we can measure the short circuit current and also short circuit voltage also. Short circuit current we can measure here. Okay, but in the previous stage, whatever seeing in the without applying load, we can't see the exact short circuit current because whenever short circuit the short switch, it will become short circuited. It will changes some current. Then the fuse it detects the short circuit current and it will be cut off the input supply. But if it comes to the with applying load, here it will take some fraction of seconds to cut off the supply because there should be resistance is opposes the short circuit current. So here there is a short circuit with load. And here there is a wiring diagram of for OC and AC test. This is the circuit and here there is a phase and neutral. It is connected to the supply and we can connect the ammeter in series with the lamp indicator and there is a voltmeter is connected with across the phase and neutral and here we can see here L1, L2 and L3 it is connected. This is the short circuit switch. Okay, it is connected to the resistive load. So this is all a very simple circuit. to do the short circuit. As per the procedures we need to follow. Here we have procedures. First, keep short circuit switch in off position. Keep the switches S1, S2, S3 in off position. Connect 230 volts to the phase and neutral. Connect AC voltmeter and AC ammeter after the fuse. Connect output terminals to load terminals as shown in the figure. Switch on the main supply. Note down the voltmeter reading and turn on the MCB. In input side, you need to note down the voltmeter reading. After that, you need to turn on the MCB. The ammeter shows zero current because it is an open circuit. Note down the voltmeter reading, ammeter readings using multimeter, and turn off the supply and remove the circuit connection. Here there is a short circuit test. Keep switches S1, S2, S3 in off position. Keep the MCB in on position. Shorting switch in off position. Connect the 230 volts supply. Connect AC voltmeter. Connect output terminals to the load terminals as shown in figure. Switch on the main supply. The voltmeter will indicate the supply AC mains voltage, that is 230 volts. The lamp indicator will on since there is a current flow. The ammeter reads total current in the circuit. Switch on the short circuit switch and note down the VS and ISC and VSC. This is without applying the load. And there is a short circuit current with load. Keep the switches S1, S2, S3 is on position. Keep the MCB in on position. Short switching in off position. Keep the rheostat in cutout position. Repeat the steps from 1 to 7. Increase the rheostat value observing the readings of ammeter. So you can easily find out the MCB trips after short circuit condition. Note down the VS and ISC and VSC. Turn off the mains. So these are the procedures. Here we have the tabular column, open circuit test, serial number, VS, VOC, IOC, that is open circuit. In this stage, the current is 0, voltage will be same as supply voltage, that is 232 volts. In short circuit, the supply voltage is 232, short circuit voltage is 0, current it shows 3 to 4 amps whenever it is short circuited. And if it comes to the short circuit with load, it is the 232 volts is input supply and output voltage is 0. And whatever the short circuit current, it shows about 4.5 amps as per the demonstration. So as per in this result, in this what is the objective of this experiment is to analyze the open circuit test or short circuit test, and also that with applying load, without applying load, we need to do in this experiment. Next, we can go for demonstration video. Okay. This is experiment 8, study of the effect of open and short circuit in simple circuits. This is the demonstration video. This is the wiring diagram of our OC and AC test. And in this diagram, you can see the ammeter, voltmeter, and this is the short circuit and open circuit board, and there should be resistive load. Okay. This is the components. This is ammeter 1. That is ammeter is connected in this open circuit and short circuit experiment, and this is a voltmeter, and this is the resistive load, and this is the multimeter to see the output, and this is the study of effect of open circuit and short circuit board. Okay, in this connection, first we need to connect the ammeter. The ammeter has to connect it through, there should be 2 leads. One is lead is connected here, there is a nearby MCB, and in the nearby MCB another wire it is connected to here. This is the connection of ammeter, and after that we need to give the supply. It is connected here, the single phase supply, it is connected already, and after that we need to connect the voltmeter, that is across this yellow wire. You can see this wire, it is connected to common, and 300 volts is connected to, this is a single phase, that's why we need to do we need to connect single phase. This is 300 volts here, and after that we need to connect the load, that is, you can see this is the black lead, this black lead, it has to connect it to the load, and there is a yellow lead is connected to the yellow lead of the short circuit board, and next one same, it is similar to another lead, This black lead is connected to here. You can see this is a black lead, and it is connected. And there is another one is yellow lead is connected here to the resistor load. Same as here, the yellow lead is connected to resistor load, and this is connected to the black lead. It's connected to the resistor load. And after that, just you need to do the connection. This has to neutral has to be shorted here, okay, and phase has to be shorted. And to see the output voltage, that is from the phase and neutral, this is a phase and neutral, it has to connect it to the multimeter. And here we have one MCB, one lamp indicator to indicate the power line, and there is a switch to do the short circuit. So these are the connections of the short circuit and open circuit experiment.
Start.
Okay, first we need to take the readings for open circuit analysis. In the open circuit, first we need to on the switch on the supply. Whenever you switch on the supply, you can get it here. This is a voltmeter. We are showing here is input voltage, that is 230 volts, 232 volts. And after that, we need to turn on the MCB. So it is you need to turn on the MCB. After turn on the MCB, you can get it the output voltage from multimeter, that is 232. So here we have two voltage. One is input voltage, that is 232, and the output voltage what we are getting, it is 232. So that we need to note down. First is 232 input voltage, and VOC open circuit voltage is also 232. But what about the current? We need to see the current is showing 0. You can see here current is showing 0. That is the first analysis, that is open circuit. So the open circuit voltage is 232. Input supply is 232. Open circuit voltage is 232, and current in the open circuit it is 0. Next, we need to do this short circuit without load. We need to do this short circuit without load. The supply voltage will be same as the previous, that is 232 we need to give. But we need to see the before short circuit without applying load, what is the voltage. So we need to do the short circuit, then we can come here. So it is also similar. The MCB is on, then it's showing some multimeter showing some reading, that is whatever the output voltage. Here there is a short switch, just you need to turn on the short switch. But here you can see the fluctuation in the ammeter while turn on the short switch. Just you can see here the fluctuation. You can see whenever the short circuit occurs, immediately current becomes maximum and voltage becomes 0. After the short circuit, current becomes 0 because of the fuse. The fuse will be tripped and the MCB will be tripped. So this is the one of the process for short circuit analysis without applying load. So there is some variation in the ammeter and the voltage becomes 0. The voltage becomes 0 because of the short circuit without applying any load. So after short circuit without applying load, the voltage is 0 volts, but current it can vary about 3 to 4 amps. Okay, the variation it will be 3 to 4 amps. After that it becomes 0. So this is the short circuit no load. So here the short circuit with applying the load. Here the supply voltage should be on, MCB should be on, and after it will show the some output voltage, and also here there is an input voltage same as 232 volts. With applying load means we need to apply the load by switch on the S1, S2, S3. So in this time we need to note down the current, that is 4.5. It is the short circuit current. The voltage should be 232, and also output voltage we are getting 220 volts. Within some fraction of time it will take to short circuit because of the load. It reaches to maximum current. Whenever it reaches to maximum current, then it will be trips. You can go through here. Come here. Here you can see the current. Immediately it will be shut down. The current becomes 0. So this is called as short circuit with load. So we need to note down that is a 4.5 amps. So in this tableau we need to note down that
the supply voltage is 232 volts. After short circuit, the current voltage should be 0, and current what we seen in the while taking the reading, that is 4.5 amps. So after the short circuit, it become 0 amps. So this is the one of the connection, and this is one of the demonstration video of the short circuit and open circuit experiment.